Good afternoon, everyone. My name is Bob O'Barra, and I am one of the assistant directors in the scientific computing team here at Kitware. While everyone's getting settled in, I thought I'd take a moment and introduce Kitware itself. We're a leader in software and AI research and development, partnering with government agencies, industrial leaders, academic institutions to tackle complex challenges in computer vision, medical imaging, scientific computing, and high-performance software systems. Our main mission is to build cutting-edge open-source tools that can accelerate discovery and empower innovations, whether or not it's in the lab, in the clinic, or in the field. Our team consists of over 200 engineers, researchers, developers, spread across 6 offices in US and Europe, including New York, which is our main headquarters, North Carolina, New Mexico, Virginia, Minnesota, and Lyon, France. This distributed collaborative culture fuels our ability to really deliver impactful solutions on a global scale. At the heart of Kitware's philosophy is our deep commitment to open source. We believe in building sustainable platforms that bring communities together, platforms like Tram, 3D Slicer, and today's spotlight, ParaView. These tools just don't solve problems, they encourage collaboration, accelerate progress, and form the foundation for the next generation of innovations. Our platforms are designed to empower users with scalable, high-performance solutions for solving today's most complex problems. Here are just a couple of examples of our flagship technologies that we develop and maintain. VDK and ParaView, industrial standard tools for 3D analysis, simulation visualization, and scientific computing at scale. CMake, a ubiquitous build system used by millions of developers to streamline software compilation and project management. We also have the Pulse Physiological Engine, a dynamic simulation of human physiology used in healthcare training, medical research, and clinical decision support. And Viami and Quiver, which are advanced computer vision machine learning platforms that empower automated analysis of video and imagery in defense, security, and environmental modeling. These and many other software platforms are trusted and adopted globally by research institutes, global and government agencies, and industrial leaders alike. They're not just tools, they're catalysts for collaboration, reproducibility, and breakthrough discoveries. With that said, I'd now like to introduce Cory Quammen, who is another member of our scientific computing team and is the manager of this ParaView effort here at Kitware.
Thanks, Bob. I really appreciate the introduction, and thanks for giving an overview on Kitware and our platforms here. Good morning, good afternoon, good evening, whenever you are watching this. Welcome to our live attendees, or if you're watching the recording, I'm glad that you're doing so. I'm really excited today to talk about a major new release of ParaView coming up. That's ParaView 6.0. We'll start out by giving you an overview of the talk here. We're going to start with talking about the release timeline. It's not out yet, but it's coming soon. We'll go over some highlights of the new release, talk about improvements in the user experience, new improvements in file readers and filters, highlight some of the work that's been going on in supporting novel dataset types, and give you an overview of some other miscellaneous improvements that we always have in new versions of ParaView. Finally, at the end, we'll have a Q&A session, but throughout the session, Bob may interrupt if there's a pertinent question that you ask in your question feature on the webinar software, and interrupt and ask me to answer the question, and I will do so at that time. But I expect a lot of questions to happen, and we'll try to answer all of those at that Q&A session at the end. Now, a couple of times in the talk, we will ask you some questions through a polling mechanism through this our webinar software. So we've got 3 poll questions just to get to know you a little bit better and how you use ParaView. So with that overview, we'll begin. We have a lot of slides, and I'm going to maybe go quick, but there will be a recording for this you can view later, as well as if you've registered, you'll get a copy of the slides in PDF form afterwards. So when will ParaView 6 be out? Well, we are aiming for a feature freeze in early May 2025. And for the first time, we are planning to coordinate with a VTK minor release, and that would be VTK 9.5, also due out in that same time frame. Now that's going to be, there's a few reasons that we want to do that I won't go into too deeply, but it will hopefully improve some packaging options that we wish to provide for VTK and more so in ParaView in the future. Until then, you can get a preview of all these features I'm talking about by downloading a nightly build, and the URL is available there, or if you have a QR scanning code or application on your phone, feel free to use that. These links will also be available in the PDF slide copy that you get if you want to look later. So let's start out with some highlights in this release. It's always hard to pick some of the top highlights, but the first one is maybe the most obvious change in ParaView 6.0. That change is the use of a new default color map. So when you start ParaView, you load some data, you color by a data value. ParaView says, hey, I'll use this color map. I have to pick one, and we had one for many years now, probably over a decade, this cool to warm color map that is a nice, has some nice perceptual properties. But some more recent work in color map development by folks in the broader ParaView community, like Francesca Samsel and Alan Scott and Ken Moreland, have rethought what would be an improved color map, and they have proposed the fast color map that, with some community feedback, we have decided to adopt in ParaView 6.0. So you can see the difference between in a couple data sets here, between the old color map, cool to warm, and the newer color map, is fast here. So it's a diverging color scale again, with some nice linear changes from the middle to the top region and the middle down to the bottom value region. And if you look at these images closely, you can discriminate some more data changes in regions around here, where it's a little bit harder to discriminate with the cool to warm color map. Two versions of that color map, where we've just taken one end of, or one half of each color map, are also provided if you want to have just linear variants of that fast color map. You'll also notice that we've changed from this bluish gray color, that's the default background, to just a more warm gray color. That was part of the same process of deciding what would be a better color map and background combination for general visualization purposes. If you'd like to find out more about the reasoning and the virtues of these new color maps and backgrounds, please take a look at a blog post with more information. That blog post also links to the publication in IEEE Computer Graphics and Applications that the creators of this color map and background have produced. Another big change comes in how we package ParaView for Linux in particular. So graphics are complicated. Sometimes you might have a system where you want to run ParaView that has X11, it's a headed display, you can use OpenGL. Other times you might have GPUs, but no X11 or other windowing system. So you might have EGL available to provide GPU accelerated rendering. Sometimes you might want to run it on computer hardware that's just CPU. There's no graphics acceleration at all, and you need to rely on some software rendering. So before ParaView 6.0, we had to build different versions for all of those cases of ParaView binaries that you could download and then use. And so you had to choose which one to use and install, and had to match the environment on your machine. Starting with ParaView 6.0, we can provide a single binary package for Linux that dynamically examines the graphics environment available to it. Basically, it tries an order of trying to load OpenGL. If that doesn't work, or try to create an X-enabled window. If that doesn't work, try to create an EGL window. If that doesn't work, fall back to the software rendering. So this will work automatically, transparently. You don't need to do anything to get that behavior. But if you prefer to choose, or if you want to tell it which one to use, there's an environment variable called BTK default OpenGL window, which you can set. There's some documentation on the different valid values where you can specify which windowing environment to use. So hopefully this has this has actually been a long time goal that we've had, and we've always scratched our heads exactly how to do it. And our talented engineers have figured out how to do that with this release. So there are a few new ways to interrogate your data. So if you clip or slice your data, we provide 3D interactive widgets to specify the kind of clipping or the kind of slicing to do. ParaView 6 has 3 new such widgets. There's an annulus widget, it's kind of a cylinder within a cylinder in the top right. There's a frustum widget and a cone widget. So some new tools to select, downsample your data. If you use ParaView to read and visualize EnSight Gold, ASCII or binary files, you've been able to do that for a long time in ParaView, but we took the opportunity to rewrite the reader to fill in a few feature gaps, solve some bugs, and improve maintainability. So now this new reader supports things like a rigid transforms in EnSight files, and we've managed to streamline the code to avoid up to 4 times duplication. And so that just leads to more maintainability and hopefully easier to add support for any missing features in the future or address bugs as they are discovered. Both serial and parallel reading are supported in this new reader. And for the time being, the new EnSight Gold reader will be available through this plugin called EnSight Gold Combined Reader. We do this when we rewrite a reader. First, we provide it as a plugin so people can use it, try it, debug it, and we can debug it if any issues arise. Then probably in 6.1, we'll switch this to be the default EnSight Gold file reader and provide a legacy plugin so that if something doesn't work with the new reader for some reason, you can load the old reader and use that. And eventually, we'll replace the current EnSight Gold readers with the brand new version that we've created. We've added a lot of capabilities in ParaView support for caves and head-mounted displays. One of those capabilities is improved collaboration, and that is a way for multiple users to join in one session, see avatars of each other. You can see that on the screen here. There's a cave environment and a head-mounted display environment. They're actually in the same virtual environment. Maybe it's not the most compelling case because they're actually in the same room and they can just look at the cave, but the idea is you could be somewhere else with your head-mounted display and join interactive data session. So you can see avatars of each other, you can share viewpoints. So that is a new capability in the CAVE interaction plugin, which drives CAVE displays with ParaView. Other notable CAVE improvements include the ability to write in Python programmable interactors that translate motions from the input pointer devices into interactions with the ParaView data space, either moving objects around or changing the navigation of where you are. That can all be done with Python now, which has greatly improved the ability to customize how you interact in a virtual world. This is only available in the CAVE interaction plugin. There's some nice features to make windows behave better with your windowing system. And there's some capabilities to get information about the display configuration on the client. Normally that just resides on the server. So, a lot of improvements to CAVE and HMD support in ParaView 6.0. That brings us to our first poll question. I need to pull that up here. And the first poll question is, what is your professional or academic background? We want to get to know a little bit about you. And so I'm going to launch the poll, and something I believe will pop up on your screen, and you can tell us a little bit about yourself. And I'll just give another maybe 15 seconds or so as you figure out the controls and respond. Okay, great. Any last responses? All right, I'm going to end the poll and see the results here. So we have a couple of students here. welcome. Number of industry professionals and computational scientists. Industry professional is probably a wide category here, but computational scientists, great. I hope you use ParaView to view your results. R&D support and a couple others. Welcome all, and thank you for letting us know a little bit about you. And with that, we'll cover some new features that improve the user experience in ParaView. So first is, there are a couple options when it comes to customizing ParaView's values in the various filters or readers that it provides. We make our best guess as developers as what reasonable values are. Typically we're wrong, and you probably have better ideas. With values, I mean things like isosurface values or different features in readers, like turning options on and off. So for a long time, we've in ParaView had the capability of setting custom default values, but it's been tricky to change those and then reset to your customs. You could reset to the application default, the values we determined as developers, but it wasn't possible to reset to your custom value before. Now it is. There's a new menu item when you reset. If you get a context menu by clicking on the label of the property, this is a new menu item available there. There's a new setting in the General Settings tab that lets you preserve property values. Basically, this mode is any value I enter as a property value, I want to be my new custom default value. And in other words, anytime I create a new reader of a certain type or a filter of a certain type, I want these values to always be the ones that are initialized in there. So this option does that for you. And all those custom values are saved using our custom default values mechanism. So that means they're all those properties are preserved across different ParaView sessions you might run. There are a couple additions to the color map editor, relevant to the color map editor. On the toolbar button that you can use to bring up the color map editor, that's now toggleable, which means you can either show or hide the color map editor by clicking on this button here. Before, you could only use it to bring it up. In the color map editor itself, there are a couple new options for rescaling your color map data ranges. So the minimum and maximum values that corresponds to the lowest and highest colors in your color map. There's a rescale to visible data range on apply. So when you hit the apply button, that will update the color map minimum and maximum to only what's visible in the current view you have selected. And then there's a second option, rescale to the visible data every time step. So if you're playing an animation, this will adjust the data range with every time step that's being loaded into ParaView. There are a couple of time handling changes in ParaView. So before, if you loaded just a single time step in ParaView, we would say, well, let's just call that 10 time steps. And there are some reasons we did that, maybe not great ones. And so we've changed that now. So now when you load one time step, you have one time step. If you want to create an animation using that one time step, you can do that, no problem. You just have to go to the time manager and set the number of frames to some other value. So in this case, I set it to 100. And then if you are know ParaView well and set up an animation, then the animation will play over 100 different like fake time steps, right, that you define that aren't controlled by the data that you have ingested. Another nice little kind of bug fix kind of feature is that the time controls, you can just change the playing direction while the animation is playing. Before you had to stop it and reverse the direction, but now you can just change that, either play it forward or play it backwards. You may notice in the toolbar a couple of additions and a subtraction. So these additions here are cell data to point data. It's used by quite a few people. So there's a new icon that represents that, and that will create a new cell data to point data filter. And then there's another icon that will create a resample to image filter. In the data analysis toolbar, there's an integrate variables icon, which is an oft-used filter to integrate across a surface or volume. We removed the extract region of interest icon from here, which you obviously don't see because it's removed, but that we felt was a less used filter. As you work with ParaView, we try to solve all the bugs, prevent all the crashes we can, and we're not perfect people. So one thing you want to do is save the state of your work. There's a new way to do that automatically, so you don't have to go through File, Save States, and do that every time you want to make sure you've captured all the work you've done. This will just automatically save either a PVSM file, which is our XML format that describes state, or a Python state file, which is a Python script that, when run, will recreate the state that you have in your session. So this is a setting. Every time you modify just about anything in ParaView, that state will be saved to a file, so that if for some reason there's a crash or a problem, or you run out of allocated time on your system, you can keep that state file and access that. Details of this, where that state file is selected or is saved, will be available in the full release notes for ParaView 6. If you work with ParaView in a client and server setup, then there are some improvements for how you specify SSH connections to do that. There's an environment variable that lets you supply command line options to your SSH client. So that's ParaView SSH options environment variable. And then in the ParaView server description, XML, there's a new support for in the SSH command element to say that you want to use a randomly selected port in some range. So that's a PVSSH PF server port option. Again, the release notes will have some more details about how to use this and what this does for you. That brings us to file readers in ParaView. New readers and some improvements and other improvements to just work with files. So first off, there's an option in the Files menu that's been there for a while to reload files. It was a little surprising because that would only really reload the file that you have selected in your pipeline browser. And other files or file readers wouldn't be updated. So it might miss some new time steps or some changes in the data if it's being dynamically written as you're processing the data. So now that menu option reloads all the reader sources in the pipeline browser. You can still reload just the one you want that is selected in the pipeline browser by left-clicking on it or right-clicking on it, or sorry, control-clicking on it or right-clicking on it, pulling up the context menu, and then just reload the files for that reader. We did some work. If you use OpenFOAM, there's some great improvements in the file reading speed targeted to network file systems in particular. So we did some tests on a 1 gig E network, loading up a very large OpenFOAM data set and optimize the performance there. Really what we want to do is saturate the network as much as possible while iterating over time steps. So we made some improvements across a number of different areas, including the reader, but also in extracting things like the boundary faces from polyhedral data sets that are defined that might be defined in the OpenFOAM reader. That will also apply to extracting faces from other polyhedral data set formats, not just OpenFOAM. And then a 32 times improvement in appending parts of the data set together. So that's a part of ParaView that was serial and slow, and our talented engineers have improved that performance by quite a bit. So this bottom graph that you see here shows network activity on a 1 gig E network. And what we want to do while we're playing through a time series is peg that network bandwidth at the peak, which is about 120 megabytes a second. So I've annotated that line here because the scale is a little bit hard to see here, but we're iterating over 5 data sets here. And so most of that time we're spent just saturating the network bandwidth. That's as fast as we can read the data off the network. And then there's some processing between that reading that ParaView has to do to show you the results. So this is a lot better performance, especially in this scenario where you have open foam data sets with lots of different files, lots of different folders on a network file system. There's a new AV mesh file format reader, and this comes out of the Department of Defense HPCMP, the High Performance Computing Modernization Program's Create AV program. There are a number of applications that are used for air vehicle design and modeling, and they write out to this data file format. And for more information about Create AV, there's a link here in a QR code. There's a new X-Array CFR reader plugin. So this is a plugin that uses X-Array to read ZAR, which are these large cloud-ready multidimensional chunked data format files. And then GRIB is a special kind of X-Array format that is targeted towards storing atmospheric data from weather simulations. Now, this is a Python-only plugin, and it has some Python dependencies that we're not shipping with ParaView 6.0, but we have a way to use a virtual environment with a parallel Python installation in which you install those dependencies, and once those are installed, you can use this plugin. There'll be a future blog post detailing how to use this plugin coming up very shortly. Some nice things in the delimited reader. This is used to read CSV files. So we have a preview of the contents in the properties panel. There's a new option to skip a number of lines. So this is helpful if you've got a sort of CSV-based format where folks have decided to add some lines to the format that normally would choke the delimited text reader. And then there's a comment character option where you can say, if any of these comment characters are found, then stop reading the data on that line beyond that comment character. A couple nice improvements to that reader. We have some better time support available for a couple of, or the LAMPS dump file format. So now you can read a file series of LAMPS dump files. And all the visit-based readers now provide the actual time value for a single time step, if you're loading just a single time step. There's a number of visit-based readers that we provide with ParaView, and this is something that was missing from them that's now fixed. VTK's growing HDF file format has seen some improvements, and some of those are available in ParaView 6.0. There's new support for the HyperTreeGrid data structure. There's some removal of a merge parts property that may affect you. If you use this property in the reader before, you would have to basically add a merge filter after the HDF reader, and then just select the option to only merge different parts. So there's a very similar option in there. There's been improvements in reading distributed composite data sets in this reader. And now the writer that's available in ParaView is able to write temporal distributed composite data files. So always some new developments in the VTK HDF format that is continuing to evolve and improve. And that brings us to our second poll question. I'm interested in finding out, what types of files are you frequently loading into ParaView? So let's run that one. And again, we'll maybe take 20 or 30 seconds here. I'm sorry if you open other file formats. We only have so many options we can provide in the polling mechanism here. This is my best guess at the maybe most frequently used. All right, we've got about 74% of people voting. Thanks so much for that. And we see that there are about 78% folks use BTK file formats, either XML, legacy, or HDF, followed up by EnSight case files, 30%, OpenFOAM at 30%. Some use XDMF and some use Exodus. So thanks for those responses. Very interesting information. All right, next brings us to our improvements in different filters. There's a new quadric decimation filter that's available to reduce the number of triangles in a triangulated mesh. That has a target reduction property that you can set that specifies roughly the ratio of the new to the old triangles that you want to produce in the output. So here's an example where we've gone from 11,000 triangles down to about 5,500. And it does a pretty great job preserving shape and features on the data set. There's a new feature edges region IDs filter, which probably the easiest way to explain it, in my mind, is that it goes through your data set and labels all the regions that are relatively flat. All right, so if you had a box, it would label each box's side by a different region ID. You can control the maximum dihedral angle between neighboring triangles to define what that flatness measure means. So a larger angle would be more tolerant of not flat surfaces, and a small angle would be less tolerant and break things into more regions. This adds a cell data array with that region ID that you can then use to filter out. Then you can use that array in any number of ways that you want. There's an axis-aligned reflection filter that's available now, and this just reflects across X or Y or Z. There's some interactive controls for defining that plane, but that plane is fixed in one of the orthogonal axes directions. This supports HyperTreeGrids, and more axis-aligned versions of the filters are planned for the future. There's a number of filter performance improvements. So I mentioned these with the OpenFOAM reader, but the append filters have been multi-threaded, and a number of easy performance improvements and better use of better code organization has led to much reduced time and execution for the append filters. And the extract surface and surface representations are improved for polyhedrons, in particular, extracting faces of polyhedra. That brings us to our third poll question already, and this will be the last one for this session. And that question is, which ParaView filter is one that you typically apply first to your data? Is there a go-to one? So again, my best guess is things we have in the toolbar. What's the first thing you go to when you loaded a data set? Okay, wait a few more seconds. Other, okay, well, I will end the poll and share the results here. So, okay. So other comes in at number 1. So I guess I sort of missed the mark on which one to apply. I'd be curious. I had other options like calculator. I'm not sure what else, or I forget what I put, or extract. So maybe, yeah, maybe in the Q&A we can find out more about what you're using. But slice is often used, contour, clipping, and then cell data to point data. Okay, I would have guessed that one maybe would be used more. OpenFOAM, for example, but I guess there's an option to do cell data to point data in the OpenFOAM reader itself. So maybe not, maybe you don't need to use that. Okay, so we'll continue on. There's a couple of improvements, or a number of improvements on what I call novel dataset types in ParaView 6.0. We'll start with quite a few additions to support HyperTreeGrids. So there's a new ability for the HyperTreeGrid source to produce masked cells, which won't be used in computation and possibly even displayed. There are some new filters targeted towards HyperTreeGrids. This feature edges filter works on those data sets now, along with this axis aligned reflection filter we talked about, and the transform filter now all support HyperTreeGrids. There's a new filter to generate fields in HyperTreeGrids, and the HyperTreeGrid surface representation now supports a multi-block visibility selection in the multi-block inspector. And there have been a number of performance and memory usage improvements in that representation as well. HyperTreeGrid support keeps maturing in ParaView, including in this version. Next up, we are working on a multi-year effort to support novel cell grids and cell formulations in VTK and ParaView. So this is a more general data representation than what VTK has supported in the past and what ParaView has supported in the past. It lets you specify novel mesh cell types and different function spaces within cells, lets you support things like discontinuous Galerkin meshes. So now we have support in the IOSS reader that reads Exodus files to read in cell data from these novel mesh types. So it reads discontinuous hcurl, and hdiff fields. We've also added support for other operations in ParaView for these mesh types, including hardware picking of objects in the scene, and CPU and GPU interpolation of basis functions. So what that means is you can put the basis functions on the GPU and do tessellation there, rather than tessellate on the CPU and send a whole bunch of geometry to the GPU for rendering. And we've added some sources and filters that are relevant to cell grids. So there's a cell grid there's a cell grid source now that you can use to create example data sets, cell grid to unstructured grid to convert cell grids to unstructured grid types that have support for some filters that may not be available for cell grids themselves. Cell grid transform and the cell grid warp filter are all there. And this is, as I mentioned, a multi-year effort to continue to support these types of grids, and we will continue on in future versions of ParaView. On the right, you see an example of a data set, of a cell grid data set where there are discontinuities at cell boundaries and even intracell variation. You can spot that on some of the cells up here. Things that were not possible in the standard data types in ParaView before. I wanted to point out there's more information on the discourse post on our VTK discourse instance if you want to click to find out more about what's supported. Now, here comes sort of the miscellaneous section, and we'll end with some things that are relevant to people who develop with ParaView. So NVIDIA has provided an update for their index volume rendering plugin. So this has some new requirements on minimum CUDA version and compute capability. And it supports the new Blackwell architecture as well. So it will support Maxwell through Blackwell architectures. There's some NVIDIA driver version updates required. These are the minimum. So the release notes will have some recommended drivers, but look for an updated index plugin in 6.0. A couple miscellaneous Python related improvements here. So we worked on improving autocomplete in the ParaView application's Python shell. So before, autocomplete was pretty much limited to the first element after the dots. You could autocomplete, say, the slice type or other properties of the active source. But we've extended that to enable autocompletion for parts of the expression further past that initial dot. So look for some improvements in Python shell completion. The ParaView simple module, that is used to do a lot of Python scripting to control ParaView, has been refactored, and a lot of functions that have some common theme have been separated into different Python modules in a logical way. That shouldn't really change things if you just import ParaView simple. Your scripts will work just like before, but it's just a little bit of management on the developer side, on our side, to make things a little bit easier to deal with. There's a more generic default grouping filter used in the server manager.fetch function, which is used to grab data from the server and bring it to the client if you wanted to do client-side processing. That it uses a more general group datasets filter rather than the multi-block data group filter as the filter that's applied after gathering all the results from the server onto rank 0. That's a more general filter that lets you produce partition dataset collections rather than multi-block datasets. So kind of a subtle but potentially important change there if you use that fetch function. Some new configuration options for ParaView. That includes a site settings.ini file, which stores certain properties or certain settings for the ParaView user interface, things like which windows are open, where they're positioned, and so on. So that is used as fallback if you don't have any user specified settings available. Like for the first time you run ParaView, you won't have any user settings available. So it will consult the site settings file if that exists. This is a way to configure ParaView's initial appearance across for all users at a given site where that ParaView might be installed. There's some refactoring of the logic used in multiple settings files. This makes things improved for maintainability for us. Then there's the ability to customize what is shown in ParaView. So ParaView is kind of a kitchen sink application where everything in the kitchen sink is visible. There's a way to hide things that are not important with this properties panel visibility JSON file. You can define that and put that alongside the user settings file, and that ParaView will consult it to decide which properties to hide if there are any defined in there. So it could be useful for customizing ParaView at a given site installation. ParaView lets you export scenes using the VTK.js exporter, which is kind of nice because it lets you export to basically a web page that people can load in their web browser and interact with the data that's exported. It lets you now select arrays to export. That's easier to set up and select the Glance application. So Glance is sort of a somewhat general purpose web app for visualizing data. There's an option to bundle the VTK.js in a Glance app or export it as a separate web page without Glance. And there's an option to disable network requests from that exported Glance request, which could be important if you're in some kind of secure environment. In Catalyst, there is now a way to designate what arrays in your simulation are certain attribute types in ParaView or VTK. So some arrays are important in VTK, things like ghost points or ghost cells. And before, it wasn't really easy to define a ghost points or ghost cells array through Catalyst, but now you can explicitly say this array is a ghost cell array using this attribute type and some custom metadata from your Catalyst definition tree. And this tells ParaView exactly what each array is supposed to be. So then there's another feature to replace some values with other values, and this can be useful if your simulation, say, defines a ghost cell with one value. ParaView expects a different value, and you could just perform that remapping. Do that in whenever the Catalyst data updates. And then lastly, we're now packaging the ParaView Catalyst with the Windows and macOS binary packages of ParaView. Those were not available before. Some developer notes. So ParaView has moved to require C++ 17. That included some new minimum compiler versions that we support. They're all listed here. We are now using Qt6. We're fully support Qt6, and we're building and packaging with Qt6. So if you install one of those nightly downloads I pointed you to earlier, that will be using Qt6. There is a new, more accurate image testing framework we're using to catch regressions. There are fewer false negatives in tests. There were actually some very surprising differences that were allowed in the old image testing framework. If you're using this to test your plugins, then you might notice some failures you didn't notice before, because that testing framework is is pickier and more accurate and a little bit more sensitive. So lastly, there's some improved performance in the PV array information. So copying from arrays, which would be an expensive operation if your data set has a lot of arrays. That's been improved and sped up. There are some new things to be aware of if you're using ParaView as a base application and customizing it. There's a new example or application core class for ParaView-based applications that you can use. And CMake now exposes a QCH file that is ParaView's, basically contains ParaView's online help. So you can use that in your custom application, include all of ParaView's help and then yours as well. That property visibility JSON file I mentioned before, that's available through a PQ property panel visibilities behavior that's new. You can add that to your custom application and use that to really pare down the options that ParaView presents in your custom application. And there's some refactoring, providing some standard path locations of interest to application developers, like system, install, user directory paths, and so on. And lastly, there is a way to read plugin version descriptions from a plugin configuration file without loading a plugin. And this can be important if your plugin is sizable, large, and it's maybe slow to load. This is a faster way to get version and description information that's available now. So that ends the what's new in ParaView 6.0. I hope I provided some interesting information for you. Get started at paraview.org. All our downloads are there. And again, grab a nightly to try out these new features. If you need help, we have a ParaView discourse forum at discourse.paraview.org. We offer courses. There's information about courses here. We don't have any public courses scheduled yet, but plan to probably will have some in the near future available at the webpage listed there. We also offer private courses for your organization if you're interested in doing that. As some of the core developers behind ParaView, we offer paid support options. So contact us to find out more about what that might look like if you decide that you would like our help at some point with your ParaView-based application or something you'd like ParaView to do that it doesn't do currently. And we offer a full service of options from consulting, just answering questions about the development, and or to doing full custom application development for you. So please reach out if you want some more information, kitware.com/contact. And that is the end of my presentation, and we have some time for questions.
Questions are open, so please feel free.
Okay.
One quick question, Cory.
Yes.
On Linux, when it determines what backend it discovered, which one it's going to be using in the new version of ParaView, can you determine that after the application is running, for example, in the About screen? Or
so right now, no, but we are planning to add that so that you know which one you're using.
We do have a question in terms of 6.0 available yet. The answer there is not quite.
Not yet, but like I said at the beginning, we're aiming for June of this year.
We have another question. Does volume rendering support GPU acceleration like Metal on macOS?
Sorry, does volume rendering support GPU acceleration like Metal on macOS? It does support GPU acceleration. It does not use Metal directly. It's still relying on the OpenGL implementation on macOS, which is fortunately still available, though they've deprecated it some number of years ago. So, and there's lots of types of volume rendering specific to different data sets, but for sure the one that does volume rendering for image data sets, regular grids, is definitely GPU accelerated. That's on Mac and all the other platforms as well.
Cool. Just once again to reiterate, what is the target release date for 6?
So we don't have a tied down date, but June 2025.
Okay. Another person has asked, how is the resource allocation compared against ParaView 5.x? in terms of things such as RAM and CPU, for example?
Right. Well, that's almost, well, that's a very broad question, and the answer is it depends on any particular part of ParaView that you're using, whether it's which reader, which filter. I don't have any specific data points to give you other than we have done a lot of performance improvements in terms, so this is not RAM, but more towards your CPU part of your question, multi-threading some additional algorithms that had not been multi-threaded before, making some easy optimizations that were just not in the code before. So you'll see that, but not necessarily across the board, although for the last 3 or so years, we've done a lot of that work in performance improvement. But the difference between 5.13 and 6.0, you'll just see in a couple different areas, especially if you work with polyhedra, for example, data sets.
Another attendee has mentioned that they really appreciate the new automatic state save. And the question is, are we planning on providing more detailed information when things go wrong? For example, when the application if and when the application crashes.
Right. So there is some ability. I think there's definitely a command line option. I'm not sure if it's available in the binaries that are available for download to say print a stack trace, which is very developer oriented and might not be that helpful for you to know on the end user side what exactly went wrong, but would be informative to us to know what went wrong. We haven't undertaken any other efforts that come to mind to provide more information upon a crash. macOS will provide some information that's meaningful to us that could always be put into a bug report or emailed to us. But within ParaView itself, we're always trying to improve warnings and errors that occur, but we might not get every single one.
Cool. Another question we have is, what is in terms of making ParaView fast in terms of responding, the question is is there a specific, what VDK libraries or algorithms are typically used to help speed up ParaView's performance?
Right. So we have, there's always exceptions, but generally speaking, I will say that we typically use a symmetric multiprocessing backend in VTK. There's a set of tools to parallelize in a multi-threading fashion, things like for loops. There's some, I think, task level parallelism available there, but just parallelizing for loops alone gets us pretty far along in using the full number of cores on your CPU. So that SMP backend in turn can use either Intel thread building blocks, the standard libraries thread algorithm. There's a sequential version that doesn't really help with multi-threading. And there might be one more but we released with Intel thread building blocks. So those are really the tools we use to accelerate different algorithms. There's been a lot of work and even some publications going back and accelerating some of the standard algorithms, like even just face extraction from a data set. We have accelerated that. That's like the basic thing that happens right away when you load ParaView is extracting those faces. It wasn't multi-threaded for a long time, and there's some tricky things you have to do there to do that right and do that efficiently. And we've done a lot of work in making that faster. So in the end, you should hopefully see a faster response from ParaView as you're loading data sets of the same size across newer and newer versions of ParaView. But
okay, I think that's most of our questions. One person did ask, I believe we will be sending out PDF copies of the slides out. So if there was
that's right.
Looking at the slides, you will be getting a copy of those. And once again, the webinar will also be posted. So if you need to, tune back in certain sections.
All right, great. Well, Well, thanks everyone for joining. It's been a pleasure.